I guess today we're going to learn about basics of Terraform. So what is Terraform? Terraform is an open source infrastructure as code tool and it is developed by HashiCorp. So using Terraform, you can define your cloud infrastructure like AWS, Azure or GCP using the code. In Terraform, you use a language called as HCL, that is HashiCorp Configuration Language. You can create resources in cloud manually also, but there we will miss the consistency. Consistency and the automation are the main reason to use IIC tools like Terraform. Generally in Terraform, we follow 4 steps approach. The first step is we create a Terraform files. That files are generally in .tf extension, and to write .tf files, we use HCL language. And the second step is to run the Terraform init command. So before deploying the resources, we have to set up the provider, right? Here provider is nothing but the cloud providers like AWS, Azure or GCP. So with Terraform init command, we initialize the provider setup. And the third step is to run the Terraform plan command. This is like the confirmation step. Before deploying the resources, Terraform plan will show what resources it going to deploy. And it will show what changes will be made. And fourth and final step is Terraform apply. This is the actual step to deploy your resources. So it will apply all the changes made to your cloud. Let's go to the demo part now. First, you have to install the Terraform. I have already installed the Terraform, but you can search for Terraform install in your browser. Then it will give the documentation for installation of Terraform. You can install Terraform in Linux, Windows, or in Mac OS also. So it will give all the documentation here like Brew on Mac OS and Chocolate on Windows and Linux steps. So you can follow these steps and install your Terraform in your machine. I have already installed the Terraform and I can run Terraform version. You can see the Terraform version here and it is the latest version. And today I'm going to use the GCP as the cloud provider. I have created a free trial account for GCP. So you can also create a free trial account on GCP and you can use it for Terraform or any exploration. So first I will create a dedicated directory and change the directory to that particular directory. So mkdir Terraform GCP demo and cd Terraform GCP demo. Then the first step is to create a .tf file. So I am going to create a file called as main.tf. Here in main.tfl, first I have to provide the provider details. So provider. So there are number of providers available for Terraform. You can search for the Terraform provider and you can browse the provider details here like AWS, Azure, GCP, Kubernetes. There are a number of other providers also available. You can use any of these. Today I'm going to use GCP, Google Cloud Platform. So you can click on that. Then you can click on documentation. And here you can see the example usage. You can copy this provider Google, then the project region you have to give. So I can copy this, give that here, provider Google. For GCP, I can use Google. For AWS, there are AWS option and for Azure option is there here. So for here project, I can copy the GCP project ID. So we'll copy that. I can give the project ID here. Then the region is fine, US Central one. Then one more thing I have to add here is the credentials to log in this particular GCP account. Generally, we provide the JSON key file of our service account of GCP or any other cloud provider. You can search for service accounts here in GCP and you can go to your service account that I have already created earlier. And I can copy the key file from this here. I've added my key file in this particular path. Then I can give the path of that key here. So provider part is done. Provider is Google, then the project of GCP and the region, then the credential to log into that particular GCP. Then I can give the resource I want to deploy here. For example, I want to create a VPC in GCP. For that, you can just search for GCP VPC from Terraform. Then you can go to that particular documentation here. Then here you can see the example usage. I can copy that. So I can paste the resource block here. Here in resource block, resource is the keyword. Then the Google Compute Network is the resource type. Then here VPC network is the local identifier. For example, in this Terraform code, if you want to later mention this VPC network, then you can mention this VPC with this particular name. That is VPC underscore network. So this is the local identifier. This name will be there in your GCP console. So this is the local identifier and this is the actual resource. So I will change the name of this particular resource now. I will give Terraform VPC demo. So that's it. You can save your main.tf file now. So first step is done. Main.tf file is created. Then the next step is Terraform init. Now you can run Terraform init here. So once I run Terraform init, it will find your provider plugin first. Here GCP plugin. Here you can see finding the latest version of HashiCorp/Google. Here you can see Terraform has been successfully initialized. So GCP provider is initialized now. So next command is Terraform plan. So this will show what we are going to deploy. Here you can see Google Compute Network, VPC network will be created. Here you can see in plan 1 to add, 0 to change, 0 to destroy. 1 to add means we are going to create one new resource. If you are updating any existing resource, that will come in change. Here 0 to change. And if you are deleting any resource, that will come in destroy. So once I reviewed all this, I can run Terraform apply command. So next command is Terraform apply. It will again show what it will do. Then you can approve this using Yes, then you can see Google Compute Network VPC network is creating. Here you can see Terraform apply is completed and one resource is added. Also, you can see the identification of that particular resource here. Terraform VPC demo is the name of that particular VPC network. And then in GCP, you can search for a VPC. You can click on VPC networks. And if I scroll down here, you can see Terraform VPC demo here. So this is the VPC network that is created from our Terraform. So that's it. And if you want to delete this resource, you can run Terraform destroy. Let's run this now. So now you can see 0 to add, 0 to change, but 1 to destroy. And it will destroy Terraform VPC demo resource. And if I approve this, you can see it is destroying my VPC network now. You can see one resource is destroyed now. And if I check in GCP now, that VPC is not there yet because that is destroyed or deleted from Terraform. So that's it. The Terraform lifecycle will be first you create the .tf file, then we run Terraform init to initialize the provider, then we run Terraform plan for confirmation step, then Terraform apply for applying your changes, then Terraform destroy to delete your resource. Hi guys, today we are going to learn how to use variables in Terraform. So in previous video, we directly deployed this main.tf file and all of these values are directly declared in the main.tf only. Now I will add these values as variables. Generally, this will be the structure of your Terraform folder. The first file is main.tf file. So it will have actual core Terraform code. Then we can have variables.tf. We declare all the variables in this particular file. Then terraform.tf was. Here we declare the actual values of these variables. We'll see how to declare those in later. Also, you can use a file called as outputs.tf. So once you run a Terraform apply and if you want to store any outputs, then you can use outputs.tf file. So I have created main.tf file and let me add the content for this main.tf file now. So this is the content I have used in last video. Let me copy this provider part. Here you can see provider is Google Means. I am going to use GCP now. Here for project and region, I am directly declaring the values in main.tf file only. So let me change that. I am going to use variables now. So I can add var dot any variable name. That is, I can give, for example, project underscore ID. Also for region, I can give var dot region. Now I have two variables, one is project ID and another one is region. To define these variables, I have to create one more file called as variables.tf. Here I can define the variable. So to define the variable, I can add variable, then the project ID, then in flower bracket, I can give the details. Also I have to give this in double quotes. Inside flower bracket, I can add the details. So here I can add a project ID, so description, that is GCP project ID, and the type is string. Then I can add one more variable, that is region variable, in double quotes I can give region, and in flower brackets I can give the details. So here description is GCP region and type is string, and default region values I have added as US Central 1. So we add actual values for variables in terraform.tf vars file. Here for project ID I have not defined any values. Values we will get it from tf vars file. But for region I have added default values. So if I don't define any values in tf vars, it will take these values by default. So I can add tf vars file now, terraform.tf vars file. So I can provide values here. So project underscore ID equal to, and I can have a value here. And also for region I can add a value here. So project ID I am going to use this value only. I have to give the values in double quotes. In the region I will add US Central 1 only. Now in main.tf file, let me create the VPC. I will add this content only that I have used in previous video. So resource is Google Compute Network. The local name will be VPC Network and the GCP name will be Terraform VPC Demo. Also I am going to add one more line here. I declare auto create subnetworks as false so that it will not create default subnets. So to create a subnet using the Terraform, I can just search for subnet Terraform GCP, something like that. And I will get a documentation here. So I have to use a Google Compute subnetwork, and here you can see the example usage. I can copy one of these. I can add that here. I can remove this part, and the secondary IP range is not required. As I can change the details here. So local identifier name will be VPC underscore subnet. In GCP it will create as a demo subnet name, and I have to add a IPCADR range. So it's the subnet IP range. I can give 10.0.0.0/24, means available IPs will be 2 to the power 32 minus 24, that is 2 to the power 8. I can use 256 IPs. So max I can use 256 IPs in this particular subnet. Then the region I will declare as the variable. So it will refer the variables.tf file. So here Terraform should know in which VPC this subnet should be created, right? For that I have to declare the network identifier here. That I have declared using Google Compute Network, that is nothing but this one. Then dot local identifier name of VPC, that is VPC network. Then dot ID means ID of this VPC network. So first it will create a VPC and it will have ID. That ID will be used by this particular subnet. So that's it. Let's save this file now. And if you want to store the output values, then I can create a file called as outputs.tf. So here I want VPC and subnet names as output. So I can declare those output and VPC name VPC underscore name, and it will take the values from Google Compute Network dot VPC underscore network dot name. So here VPC network is the local identifier of our VPC. So it will display the name of my VPC. So next I can add output subnet name. Value is Google Compute Network dot. So here VPC subnet is local identifier of my subnet, and the dot name it will print the my subnet name when it is created. So now I can run Terraform init to initialize my provider. So Terraform has been successfully initialized. Then I can run Terraform plan. So I can see one error here, invalid functional argument, that is credential. This gcp nifty key.json file is not there in this particular folder. That is the error now. So I added gcp nifty key.json file now here. Again, let me run Terraform plan. So Terraform will perform the following actions. First, it will create the VPC network. Then it will create the subnet. So it will add 2 resources and 0 change and 0 destroy. So now let's run Terraform apply. So it will ask the confirmation. So I can review all of this again and I can give yes. So now it's started creating my VPC first, then it will create my subnet. So Terraform apply is completed now and it created 2 resources. Also in outputs, I can see subnet name and VPC name. This is because I've added a outputs file here. So it created Terraform VPC demo VPC. And if I check my subnets here, I can see demo subnet here. Subnet IP range is 10.0.0/24. I guess today we are going to learn about one important file in Terraform, that is Terraform state file. So whenever we deploy our resources using Terraform, there will be one file created. That file is nothing but terraform.tf state file. So what is the importance of this Terraform state file? Generally, state file will track all the resources we created via Terraform, and it will store current values of all the resources. So you can see all the values here, like VPC name, then the resources. The resources type is nothing but Google Compute Network. That is nothing but our VPC. Then the number of instances. Those things we will get the details in this particular Terraform state file. So Terraform will use this particular state file to detect the changes during the Terraform plan or Terraform apply. So this file is very, very important. If we lost this file, we can't track any changes that we have done using the Terraform. This file will be generated by default in your project folder only. But as long as this file is in local, it is easy to lose, right? We might accidentally delete this file. And in real world production projects, multiple members will manage your infra. And those users will have their own Terraform project folder in their local machine. And if multiple users run Terraform apply, then that will cause us conflict. That's why we moved this Terraform TF state file into a remote backend. So remote backend is a central location and it can be shared across multiple users. That's where we store our Terraform TF state file. There are multiple options to use as a remote backend. For example, you can use Terraform Cloud itself, or if you are using any other cloud services, you can use AWS S3 or Azure Blob Storage, or you can use GCP GCS. Now my infra is in GCP. That's why I'm using Google Cloud Storage, that is GCS. So first we have to create the GCS storage. For that I am going to run command gcloud storage buckets create. I'm going to create a bucket with the name Terraform state demo bucket. And the storage class is standard and the location is US Central 1. Let's run this now. I got an error like gcloud storage only accepts the URLs, not in the this format. Let me change that now. I have changed that. Let's run this now. So now it is creating my bucket. Also one more thing, this Terraform TF state will track our versions also. So we have to enable the versioning for our bucket. So I can enable versioning for my bucket using gcloud update command. Let's run this now. So versioning is enabled now. Now my backend is ready. Now I can use that backend in my Terraform. For backend, I can create a separate file called as backend.tf, or I can define backend in main.tf file also. I'm going to create a separate file called as backend.tf now. So I created a backend.tf file now, and let me add the content for this file now. For backend, I can define like this. So backend, then the backend I am going to use GCS. Then the bucket name that I have created, that is Terraform state demo bucket. And the prefix is nothing but the path in that particular file path where I am going to store my Terraform state file. Now the prefix is Terraform/state. So this Terraform.tf state file is going to store in this particular state folder. Let me save this file now. Then to apply this backend changes, I have to run Terraform init command once. So I can run Terraform init now. So it starts initializing the backend, but it got an error like could not find default credentials. For this backend storage bucket, it could not find the credentials to upload this Terraform state file. For that, I can create an environment variables called as Google application credentials, and I'm going to use this GCP nifty.json my service principal credential. I'm using CMD, that's why I'm using set command. Otherwise, we can use export or any other command also. Now let me again run Terraform init. So now we can see initialize the backend acquiring the state lock, and it gives the warning like pre-existing state was found while migrating the previous local backend to the newly configured GCS backend. Also, it says no existing state was found in the newly configured GCS backend. That means there is no TF state file in my newly created bucket. Also, it asks, do you want to copy this state to the newly configured GCS backend? If I enter yes, it will copy my existing backend file to my bucket. Otherwise, it will start with an empty state. So let me enter yes now. So this is done now. I can see the message like successfully configured the backend GCS. Terraform will automatically use this backend unless the backend configuration changes. Now in GCP, I can search for GCS, and if I go to buckets, I have the one bucket here, Terraform state demo bucket. And if I go inside that bucket, I have a folder Terraform, and inside that I have a folder called a state, and inside that state folder, I have the TF state file here. And if I go to version history here, also I can see two versions here, and also I can see the comment like live object here. That means it is the current version. Now I can make some changes to my main.tf file or any other file, and let's apply those changes. Let me change my subnet name to demo subnet 2, and let's save this file now. Now I can run Terraform in it. So it says Terraform has been successfully initialized. Now I can run Terraform plan. Now we can see there will be one add and one to destroy, means one subnet will be deleted, that is demo subnet, and it will create a new subnet called as demo subnet 2 now. Now I can run Terraform apply. Here you can see acquiring the state log first. It will check the my terraform.tf state file from the backend first. Now I can approve this using yes. So this is done now. And if I check my GCP, and if I go to my VPC, that is Terraform VPC demo, and if I go to subnets here, I can see the subnet here, demo subnet 2. That earlier subnet is deleted and the new subnet is created, that is demo subnet 2. And if I go back to my GCS, and if I check my bucket, and if I go to my TF state file, and if I check version history now, here after I run Terraform apply, I can see the additional entry here. And for example, multiple users are contributing to this particular project. Then all those users will refer this the TF state file only. That's how you can avoid the conflicts. So this TF state file is very, very important. Make sure that is not corrupted. Now guys, today we are going to learn about Terraform modules. In actual production project, you have to write Terraform code as reusable code. Here reusable means same code across different environments like dev environment, stage environment, or production environment. For different environments, you can't write these Terraform configuration files again and again, right? To avoid this repetition, we have Terraform modules. So using Terraform modules, you can write clean and reusable Terraform code. So what is Terraform module? In simple terms, it is a folder which contains the Terraform configuration files. So we can say all these configuration files in a root module. Also, we can create custom modules here. For example, we can create a module called as network module, and we can define VPC, subnet, all of these in this network module. Similarly, we can create a module, something called as database module, and DB related configuration files we can add in DB module. Like this, you can create different modules for different resources. Generally, you can use these modules across different environments. So now I am going to create a module called as network module. So this will be my folder structure. We'll have files like main.tf, variables.tf, and outputs.tf that I have explained in previous sessions. Now we have one more folder called as modules folder. Inside modules directory, we can have different modules. Now I'm going to create a module called as network module. Inside the network module, we have the Terraform configuration files like main.tf, variables.tf, and outputs.tf. Let's create that now. So first I'm going to create a file called as main.tf in a network folder. I have created a modules folder, and inside that I have created a network module, and I have created a new file called as main.tf file. Here I'm going to create a VPC and a subnet. Let me add the content for VPC resource. So resource is Google Compute Network, and the name is VPC network. Also, it will not create subnetworks automatically. Then I can define another resource, that is a subnetwork. So resource is Google Compute Network, and the name is subnet. And I have defined everything using the variable. So I have to have a new file called as variables.tf inside my network folder. So let me create a variables.tf file in network folder. So here I can define all those variables. So variables are VPC name, subnet name, and subnet CID here, and the region. Also, I can have outputs.tf file here. In outputs.tf file, I can capture my VPC ID once the VPC is created. So that's it. Inside my network modules, I have defined main.tf, variables.tf, and outputs.tf files. One thing you have to notice here, inside main.tf file, I have defined only the resources and not defined the provider details here. So I have to create a main.tf file in my root directory. In that main.tf file, so I'm going to add the provider details. So I have created a main.tf file in my root folder. Here first I have to define the provider details. So I'm going to use GCP. So provider is Google. So what next? What I have to define next here? I have to define a module here. So I can define module using module. Then I can give a name. For example, VPC module. Then the flower brackets. So first I have to define the source for this particular module. So source directory will be modules/network directory. Then I can pass the values for these four variables in this main.tf file. So for VPC name, I'm going to pass demo VPC. For subnet name, demo subnet, and subnet CID is 10.0.0.0/24. means 2 to the power 32 minus 24 means 256 available address. Then the region is var.region. So I'm going to define this project ID and region in a variables.tf file in my root directory. So I'm going to create a variables.tf file in my root directory. And I'm going to define two variables here. The one is project ID and another one is region. Then I have to define the values for these two variables. In which file I'm going to define those values? In terraform.tfvars file. So I have to create a terraform.tfvars file now. Here I can just add the values for my project ID and region variables. Also optionally I can have outputs.tf file in my root directory also. Here I will have network ID. So everything is ready now. I can run a Terraform init now. Before running Terraform init, I have missed one thing in my main.tf file. What is that? I've added project ID region, but I have not added the credential. So I have to add the credentials also here. I've added my service accounts key JSON file here. I can define the credential in my provider details here. So in the main.tf file in provider block, I can define the credential. So credential, the file that is gcp nifty key.json. So now I can run Terraform init. So Terraform init is completed. You can see initializing modules also here. So VPC module in module / network directory. So what is the next step? That is Terraform plan. So in Terraform plan, you can check the resources that is going to be created or destroyed. So here I'm going to create two resources. One is VPC network and another one is subnet here. So in plan 2 to add, 0 to change, 0 to destroy. Then the last step, Terraform apply. You can again review this. It's going to create two resources. Then you can approve this using yes. I got an error here. My project name is different. I gave a different name here. Let's correct that in my tfvars file to make sure that I can again run Terraform init. Then Terraform plan. This is done. Now I can run Terraform apply also. Terraform apply. I can approve this using yes. So now you can see it is creating the resources that I have defined in my module.vpc module. So first it's going to create my VPC, then it's going to create my subnet. So that is done now. In outputs I can see my network ID, that is my VPC ID, that is nothing but demo VPC. So now if I check my GCP, I can see the demo VPC here, and if I go inside demo VPC, if I click on subnets here, I have one subnet, that is demo subnet, and the CDI range is 10.0.0.0/24. So this is how we define the modules. So you can define each modules in separate folder. Here I have created only one module, that is network module, but you can create modules like DB module or instance module. For those you can create a separate folders like network folder. Also for each module you can add a documentation file. For example, in network folder I have created a file called as readme.md. Here you can explain about this network module. For example, I have written all network resources will be created in this network module. You can create a detailed documentation in this readme file. Like this, for each module, so you can create a different readme file so that other developers also understand what you have defined here. So that's it about modules. You can use this module in different environments like dev, prod, or stage. So here this network module will be same for all these environments. Maybe these values changes. So all the configuration files that is there in this network modules will be same. So these modules can be reused for different environments. So that is the use case or main reason to create a module. Yes, today we are going to learn about data source or data blocks in Terraform. Generally, all the blocks in Terraform file is used to create or update the resources. But data block is used to fetch the existing resources. And you can refer this existing resource while creating a new resource. So in short, data block is used to fetch and refer existing resources. For example, in GCP, I already have an existing resource, that is Terraform VPC demo. That is one of the existing VPC. So now using data blocks in Terraform, I'm going to fetch this existing resource, that is Terraform VPC demo. Then I'm going to refer this existing resource to create a new firewall rule. Currently, you can see there are no firewall rules. I'm going to create a new firewall rule using Terraform. Let's create the Terraform file now. First, I'm going to create a main.tf file. First, I'm going to add the provider block. Provider will be my GCP, that is why provider is Google. Then project and region, I'm going to fetch it from my variables. Then the credentials will be this JSON file that I've already added in my project folder. Then I'm going to fetch the existing resource, that is existing VPC, using the data block. So I'm going to define data block now. In data resource type will be my VPC type, that is Google Compute Network. Then I can give a name, that is existing VPC. Then the actual resource name, that is name equal to the name of the VPC in GCP. Name of the VPC is Terraform VPC demo. Let's copy this. Let's add that VPC name here. That's it. This is the data block. This is how we can fetch the existing resources. So fetch part is complete. Let's refer this existing resource while creating the new resource. That is nothing but while creating a firewall rule. Let me add that block here. To create a new resource, I'm going to use a resource block, and the resource type will be firewall. That is Google Compute Firewall. Then the name LOSSH. Here in network, I'm going to refer the existing resource. That is nothing but existing VPC. So in network, I'm going to define data dot Google Compute Network dot existing VPC. And obviously in network, I have to add the ID of my existing VPC. That's why I have added .id here. So data dot Google Compute Network dot existing VPC, that is nothing but this name then dot id, then allow role here I have to mention the port that is ssh port that is 22, then the protocol will be tcp, then the direction that will be ingress means it will be incoming role, then the source ranges how we added 0.0.0.0/0 means entire world. This 22 port is open for entire world now, but this is not a best practice, but this is a just demo project, that's why I added 0.0.0.0/0 here. Otherwise we have to add the specific IP ranges. So that's it. Let's save this main.tf file now. Next, obviously, I have to create a variables.tf file. So variables.tf. Here I have to define two variables, that is project ID and region. Then for variable value, I have to add one more file. There is terraform.tf first file. Here, let me add my project ID. So that's it. All the files are created. Let me run Terraform init now. Terraform init. So Terraform has been successfully initialized. Let's run Terraform plan now. Here you can see for data block for existing VPC, you can see reading here, and the reading is completed after 1 second here, and it found the resource, there is Terraform VPC demo here. Then for create, I am going to add a firewall rule. So here 1 to add, 0 to change, 0 to destroy. That data block not come into picture here. Only one resource that going to create it, that is the firewall rule. Let's run Terraform apply now. Terraform apply. Here again you can review, there is one to add, that is nothing but firewall rule. Let's enter value, that is yes now. Here you can see that firewall LOSSH rule is creating. So first it will fetch the existing VPC ID, that is my Terraform VPC demo ID. Then it will add a firewall rule for that particular VPC. The firewall rule is added now. Let me check in GCP now. If I go to my Terraform VPC demo VPC, if I click on firewalls here, I can see one VPC firewall rule, and that is LOSSH rule. And if I click on allow SSH rule, I can see the port here, that is TCP 22 port, and the IP ranges will be 0.0.0.0/0. So that's it. You can fetch existing resource using data block. Then you can refer that existing resource in my resource block, like data dot this particular existing VPC. So you can fetch any existing resource using data block. For example, you want to fetch a latest image of Ubuntu VM type. For that, you can use data block like this. You can fetch the image, then you can use this image to create an VM. Or if you want to fetch an existing SSH keeper, then you can use this data block. So like this, you can use data block for fetch any existing resources. So this data block is very helpful block in Terraform. I guess let's learn some advanced topic in Terraform today. Today we are going to learn how to write scalable and modular code in Terraform. We are going to use locals, count, and for each in Terraform today. So why do we need local, count, or for each? We need this to create multiple resources, and importantly to avoid the repeating logic. So if you use this, our code will be more dynamic. Let's create the Terraform files now. First, I will create my main.tf file. Main.tf. So in main.tf, first I will add my provider block. Here project and region I will get it from the variables, and the credentials I will get it from my JSON file that I have already added it. So next I will use local, count, and for each. So here in this demo, what I'm going to do is I'm going to create 3 buckets. These are the GCS buckets, and I'm going to add these reusable bucket names in local block. And also I'm going to use count to create these buckets. And in count, I'm going to use index based approach. Also, I'm going to create a map of region with the bucket names, and I will loop through these maps using the for each loop. Let's see how it goes. So first I'm going to create a locals block. So locals. Here I will define two things. One is environment, and another one is name prefix. Environment I'm going to declare directly, that is dev, and name prefix will use on my project ID from the variables. Then hyphen local dot environment. Locals dot environment. Environment means dev here. Then I will declare the bucket names here. Basic buckets name, that is logs, media, and report. These are the 3 different GCS bucket names. Then I will add full bucket names. Here I'm going to add a for loop for name in local dot basic buckets. So it will loop through my basic buckets, logs, media, and reports. The full bucket names values should be local name prefix, that is my project ID hyphen my environment, that is dev. Hyphen name means it will go through this loop, that is logs, media, and reports. So first bucket will be logs, second bucket will be media, then third bucket will be reports. So my full bucket names will look like my project ID hyphen my environment, that is dev, then hyphen logs. Then for second bucket hyphen media, third bucket hyphen reports. Then I'm going to add a map here. So I will map each bucket with their own region. For logs, I'm going to use US Central one, and media for South one, and for reports, it is Europe West one. So that's it. I have declared everything in locals now. So now let's create buckets in 2 ways. First, I will use count. Then I will use for each. Let me declare my resource block. Resource block I will use my GCS Google Storage bucket. Then I will name it as count buckets. First I will use count now. So first I will declare the count equal to length of local dot full bucket names. Full bucket names means this one. So length of this full bucket names. And then to create my GCS resource, I have to give a name. So name equal to, so here if you are using count means I am going to use the index. So local dot full bucket names. count.index. So for names, it will check the index of my full bucket names. So for first one, it will be full bucket name of my logs. Second will be media. Third will be reports. So name will be added based on the index. Then the location, I'm going to use the var.region. So this is how we use count to create buckets based on the index. Let's create one more resource block to use my for each loop. So I'm going to use resource same GCS. Then the name I will add as for each buckets. Then I will define my for each equal to I'm going to use region map now. Then for the name, I will use local name prefix. That is this one. That is my project ID hyphen dev. Then hyphen each dot key. So key will it will check in my region map. The key will be my logs, media, and reports are key. And US central one. These regions are my values. So keys means this bucket names. Then we'll add a hyphen name to differentiate between my buckets from count and for each. Then the location. In location, I'm going to add each dot value. Value means here the region map values. That's it. Let's save this main.tf file now. So now as usual, let's create my variables.tf file. Here I will add my project ID and region variables. Let's save this file now. Then I will create my terraform.tf file. Here in tf file, I've added the values for both project ID and region here. Then I will create one more file that is outputs.tf file. In outputs, I'm going to print two things. One is full bucket names list using local.fullbucket names, and another one is for each bucket location using the local.region map location. So that's it. Let's save our outputs.tf file now. So let's deploy this now. So first I will run Terraform init to initialize my Terraform platform. So there is an error. So instead of floor bracket, I give a normal bracket here. So I'll close my floor bracket here. Let's save this now. Let's again run Terraform init. So Terraform has been successfully initialized. Let's run Terraform plan. So here in plan, you can see 6 to add, 0 to change, 0 to destroy. So 6 buckets will be created. Now let's run Terraform apply. And again, it will show 6 to add, 0 to change, 0 to destroy. And I will confirm using yes. Now it starts creating my buckets. Here you can see. So now apply is completed. 6 resources are added, and also it shows my outputs also here. So that's it. 6 buckets are created. Now let's see these buckets in my GCP. So in GCP, if I go to my cloud storage and if I go to my buckets, here you can see 6 buckets are created. So here dev logs, dev media, and dev reports are created based on my count logic. And all 3 named buckets are created using my for each logic. Also, you can see these unnamed buckets are created in one region, that is US Central 1, because that's the default region I have added in my terraform.tf file. And in case of named bucket, first bucket is created US Central 1, second bucket is created in Asia South 1, and the third bucket is created in Europe West 1. That is what I have defined in my region map logic here. You can see first bucket is in US Central 1, second bucket is Asia South 1, and third bucket is in Europe West 1. That is the logic I have added. So this is how you can make use of locals, count, and for each. I guess today we're going to learn conditional expression in Terraform. Here, conditional expression is like a branching logic. So something like this. So when the condition is met, true value will be applied. And if condition is not met, then the false value will be applied. So this is the conditional expression. Let's create a Terraform resource using conditional expression now. So first let's create main.tf file. In main.tf file, first I will add the provider block. So project and the region, then the credential files I have already added in this particular folder now. Now let's add the resource block. So here I'm going to create a Google Compute instance. Then I have defined all the details like name, machine type, zone, boot disk, network interface, tags, all these details I am going to add in this resource block. Here you can see in machine type I have used the conditional expression. So here I have the variable called as env, and if the env is prod, then the machine type will be e2 standard 4, and if env is not prod, then the machine type will be e2 micro. So like this I can use the conditional expression for true and false logic. Similarly, I have added the conditional expression in my tags also. So if the variable env is prod, then I will add production as the tag. Otherwise, I will add the development as the tag. Let's save this file now. Then obviously we need a variables.tf file. Variables.tf. Let's add the content for variables.tf file. Here I have declared the 3 variables: project ID, region, and the env. Then I need one more file called as terraform.tfvars. Here I am going to declare the actual values for my variables. Here I have added values for project ID, region, and env. For env, I have added a value as dev. Now let's run this. First, I will run Terraform init. The project is initialized now. Let's run Terraform plan. When I run Terraform plan, here you can see machine type is E2 micro. That is because I have declared env as dev. So if I check my main.tf file, if the environment is not prod, then the machine type will be E2 micro. Also for tags, if the environment is not prod, tag will be development. Here you can see the tag also. Tags is development. Now let me change my environment to prod and save this file. If I again run Terraform plan, Now the machine type is E2 standard 4 because the environment is prod. Also in the tags, I can see the production tag. Let me change the environment as pre-prod. Now if I run Terraform plan, now machine type is E2 micro, also tag is development because environment is not prod. For any environment other than the prod, this will take these values like a machine type will be E2 micro and the tag will be development. I can run Terraform apply and see now Terraform apply. Here you can see 1 to add, 0 to change, 0 to destroy. So it is going to create one VM instance. Let's type yes and accept this. Now Terraform applies complete. Here you can see conditional VM is created. Now if I go to my GCP and if I click on VM instances, you can see one VM is created, that is conditional VM. And if I click on that, here you can see the machine type is E2 micro. Also if I go to my network tags, I can see development tag here. So that's it for conditional expression. I guess today we're going to learn Terraform functions. So why do we need Terraform functions? Using Terraform functions, you can transform and manipulate values directly inside your Terraform configuration file. Terraform function useful in three ways. First one, you can avoid hard coding. And second one, it helps in data transformation. Also, it makes your configuration more dynamic and reusable. Let's start with the demo. I've already copied my credentials file here. Let's create one more file, which is main.tf. So first we have to add the provider details. Let me add that now. Here project date and region, I will add it in variables, and the credentials file I have already added here. There are multiple Terraform functions. Today I will go through some 5-6 important functions. The first function is string function. Here you can see I have defined the string function here. You can add percentages for string function. Here for first percentages, it will get the value from env variable. And for second percentages, the value will be string VM. For example, env variable is dev. Then my name will be dev hyphen string VM. So here I'm going to create a Google Compute instance resource and I'm declaring a name with the string function. So this is how we can use the string function to dynamically name a VM. The next function I am going to look into is numeric function. Here you can see I'm adding the disk size to the output. Generally, disk size will be in GB. Now using numeric function, I'm going to convert that into MB. Here you can see the multiplication sign here. That is the numeric function. So numeric function is helpful in calculating the sizes or in cost optimization and other use cases. Let me define one more file here. That is variables.tf. Let me add the values for variables.tf file here. So I've added all the required variables in this variables.tf file here. Now let's look into next function, that is collection function. In collection function, we have two things. One is join, another one is split. Here join will merge the list elements into one string and separated by a delimiter. Here it is comma. Here list I am using is label list that I can check in my variables.tf file. Here you can see the variable list is env is dev and owner is Sandesh. Similarly, split will breaks the list into a string. Here also it uses the delimiter, that is colon here. So main use case of this collection function is parsing the labels, tags, etc. Next function we are going to look into is date or time function. Here you can see I'm going to create a compute instance resource and the name for this resource will be tf-%s and %s value will be defined like this. First it will take the timestamp, then it will remove all the hyphen, space and colons and it will convert the name to lowercase. So if you want to create a resource with a unique name, time-based name, then you can use the date or time function. Then the last function I'm going to demo is lookup function. So here it is like a map. Here machine type is defined based on the environment value. For that I'm using lookup function here. If you check the variables.tf file, here you can see for dev environment E2 micro is the machine type and for prod it is E2 standard 4. Also generally will declare a default value here, that is E2 small. So that is our main.tf file. Let's save this file. Also let's create a new file, that is terraform.tfvars file. In tfvars file I have defined project ID, region, zone and env. Env is dev here. So that's it. Let's apply this now. So first run terraform init is done. Let's run terraform plan. Here you can see the outputs value here, that is disk size, that is converted into MB here using the numerical function. Also the values like first label value and the label string here. First label value is from this split function and the label string is from my join function here. Now let's run terraform apply. Let's type yes and approve this. So it created some resources but it failed in my one of the resource, that is a time-based resource. So it was not able to create the resource with this name. Basically this replace one is not able to remove the my colon and other things. That's why it failed. That's fine. Let's check other resources now. So here you can see it created dev lookup VM and dev string VM. So dev string VM is created from my string function here. So in string function I would define %s hyphen %s. In first % will be my environment value, that is dev. So the name of my VM is now dev hyphen string VM. Similarly, it created dev lookup VM also. If I check this lookup VM, so here you can see the machine type here, that is E2 micro. Here you can see for the dev environment, the machine type will be E2 micro and for prod, E2 standard 4. So my environment is dev now. So it created a machine type with E2 micro. That's what I defined in my lookup function. So that's it for today. Let's run terraform, destroy and delete all of these resources now. I can accept this using yes. So it started deleting my resources now. So it destroyed or deleted my two VMs. Hi guys, today we're going to learn one of the important Terraform command, that is Terraform import. This Terraform import command is used when you already have an existing resource in your cloud provider and you want to bring that resource into Terraform management without recreating that resource. Then for that use case, you can use Terraform import. Let's see how that works in the demo. Here in GCP, I have already created a one VM called as manual VM. This I have created manually, not using the Terraform. Let's see how we can include this manual VM into our Terraform configuration. So let's create the Terraform configuration files now. So first I will create main.tf. So here as usual, I am going to add the provider block first. So project and region, I am going to add it from my variables file, and the credentials file I have already added in this particular folder. So I am adding that file path here. Then I will just add a resource block here. This will be an empty resource block before importing my manual VM. Then let's save the main.tf file, and let's create one more file, that is variables.tf file. Here let me add all the variables here. I have added project ID, region, also I have added the zone here, and also I have updated my main.tf file also. I have added zone also here. Then let's create one more file, that is terraform.tfvars file. Let's add all the values here, project ID, region, and the zone. Now all the files are ready. Now let's run Terraform init first. Now Terraform has been successfully initialized. Now let's run our actual command, that is Terraform import. The command syntax will be Terraform import, then Google compute instance, that is what I have provided in my resource block, Google compute instance, then the resource name, that is imported VM, then the manual VM that is created in GCP. So project slash my project ID, then the zone slash the zone of this particular VM, that is US Central 1 C, then instances, and the actual GCP VM name, that is manual VM. Let's run this now. Here you can see first it will show that import is prepared. Then once it is done, it will show import is successful. Now you can run Terraform plan, but it will give a lot of error like insufficient boot disk, insufficient network interface, a lot of these errors because my resource block is still empty here in my main.tf file. Now what I can run is Terraform show command, or you can directly check your terraform.tf state file. Here you can see all the resource here, the instance that you have manually created, that is already imported using Terraform import command. Now using Terraform show output or using Terraform's tf state file, I can add the details in my resource block in main.tf file. So I have added name as manual VM, then machine type is E2 medium, then zone is US Central 1C, then the boot disk R2 delete is true, and the device name of boot disk, I can see it here in boot disk, device name is manual VM only. So I will add that device name here, manual VM. Then the network interface I kept that as default only. Now let's run Terraform plan. So still I am getting one error here, missing requirement argument, that is initialized parameter. So let me add initialized parameter here in my boot disk. Let me add size and type of my boot disk in my initialized parameter in main.tf file. So we added that here, initial parameter size is 10 and the type is PD balanced. Terraform plan. Here when I run Terraform plan, it shows that one to add and one to destroy, means it's going to delete my manual VM and it's going to create new VM. But I don't want that to happen. So you have to be very careful here. So while creating your main.tf file, here your main.tf file should match your tf state file. Otherwise it's going to delete your old VM and it's going to create a new VM. So here we can prevent this accidental deletion or accidental destroy by adding a one block called as lifecycle block here. So in a lifecycle, I can add prevent destroy equal to 2, then ignore the changes in boot disk, metadata, or any other fields I can add it. If I again run Terraform plan, still the mismatch is there, but here you can see instance cannot be destroyed because I have added a lifecycle policy here. Now I have modified ignore changes here. I have added whatever there is in red to this particular list of ignore changes. Then I have saved this file. Let's run Terraform plan now and check Terraform plan. Here you can see no changes, your infrastructure matches the configuration. Let me make some changes in my main.tf file, then I can run Terraform plan and Terraform apply. Let's make some minor changes. I'm going to change my machine type to E2 medium to E2 micro. Let's save this file now. Now let's run Terraform plan again. Now you can see 0 to add, 0 to destroy, but 1 to change. The change is the machine type from E2 medium to E2 micro. Now I can run Terraform apply. Here it will ask my approval. I can type yes. So here I'm getting one error here. To change the machine type, I have to set one config as true. That is allow stopping for update is true, because to change the machine type, it have to restart my VM. So I can add that config in my resource block here. Allow stopping for update equal to true. Let's run Terraform plan first. Here no issues, one to change, that is my machine type into medium to micro. Let's run Terraform apply now. Now it's showing that Google Compute instance is modifying. So now my Terraform applies completed, 0 added, 1 changed, and 0 destroyed. Now in my GCP, if I check my manual VM, now if I check machine type, that is E2 micron. Earlier it was E2 medium. So that's it for today. Today we have learned how to use Terraform import. Subscribe and check out other videos too and keep learning.